Hello, Algebra 2. Here we are in our last lesson in Chapter 8. So we're going to take a look at our samples for 8.7b, where we're solving systems that have quadratic equations in them. So our first sample, we're taking a look at solving these two equations. This is a circle equation, and down here we have an equation of a parabola. So we're looking to see for this circle and for this parabola where they intersect each other. And it's possible they intersect each other at no points, or 1 point, or 2 points, or 3 points, or 4 points. We're going to find all the possible points where they intersect, and that will be the solution to the system. Since this particular pair of equations has some opposite y-squareds, this would be a really good system to solve by elimination, and that's going to be the method we're going to use here. We're going to add both the equations together, and we will have x squared equals 12 minus 4x. The y-squareds will be eliminated. So once the y-squareds are eliminated, we are down to one variable. We can solve this equation. It happens to be quadratic. We notice the x squared. And we're thinking it might be a good quadratic equation to solve by factoring, since we see x squared in x terms. So we're going to subtract 12 and 4x and add 4x on both sides. That will give us x squared plus 4x minus 12 equals 0. We will factor that trinomial into x plus 6 times x minus 2 equals 0, noticing that 6 times negative 2 is negative 12, and our outside negative 2x plus our inside 6x gives us a positive 4x. And then when we solve that quadratic equation, we notice that negative 6 plus 6 is 0, 2 minus 2 is 0, so using that zero product property, setting x plus 6 equal to 0, x minus 2 equals 0, we will arrive at x is negative 6 or 2. Now we're going to see if there's any corresponding y values for these x values to see if there in fact are points of intersection for these two equations. So what we're going to do is we're going to pick one of these equations up here to plug these x values into. It doesn't matter which one you pick whichever one looks easier. I chose the x squared plus y squared equals 12. I'm going to use that to plug x in both instances to see what my corresponding y values are. Plugging negative 6 in for x squared, I'll have negative 6 squared plus y squared is 12, giving me 36 plus y squared equals 12. Subtracting 36 on both sides will give me y squared equals negative 24. And then when I take the square root of both sides, I'll be taking the square root of a negative number, which means there's no real number solution. So when x is negative 6, there is no y value, so that's not a point of intersection. Let's try plugging in 2 for x to that same equation to see if we get any corresponding y values. Here we are going to find a couple that work. So putting in 2 for x, we have 2 squared plus y squared equals 12. Subtract 4 on both sides, and we get y squared equals 8. Take the square root of both sides, we're going to have positive or negative root 8. We'll go ahead and rewrite that in simplest radical form. We break 8 down into 4 times 2. Square root of 4 comes out as 2, and the other 2 stays inside. And of course, we're getting both a positive and a negative root, so that means that there are 2 possible y values that correspond to this x value of 2. So there's 2 ordered pairs where this system will actually have points of intersection at 2 root 2 and at 2 negative 2 root 2. So it's the same x coordinate, but there's 2 different y coordinates that will correspond to that x coordinate, and so 2 different distinct points of intersection. The next 2 problems, we're going to solve systems by substitution. We're going to write our answers as ordered pairs. In both sample 2 and sample 3 that we'll do in a minute, these are good equations to solve by substitution, or they're good systems to solve by substitution, because we have at least one equation solved for a variable. So this one's solved for y. So we're going to go ahead and substitute negative 3x minus 1 into the y in that first equation. So I'm going to rewrite the entire first equation, but instead of that y, I'm putting negative 3x minus 1. Then I'm going to simplify, and I'm going to use the distributive property right here to simplify. 4 times negative 3x is negative 12x. 4 times negative 1 is negative 4. Everything else gets copied. Then I'm going to simplify that result. I'm going to go ahead and work out 6x minus 12x, and that gives me negative 6x. Negative 4 minus 3 is negative 7. The x squared gets copied. The 0 gets copied. And I have a nice quadratic trinomial here that I can factor into x plus 1 times x minus 7 equals 0. And that will give me 2 values for x that work. Either x is negative 1 or x is 7 using the zero product property. Now I'm going to again try to find 2 y values or more that match to these x values of negative 1 and 7. I'm going to choose this equation as the equation I want to plug my x into. It looks easier than the first equation. So putting -1 in for my x here, again I'm just pulling that first equation down, I will get y is equal to -3 times -1 minus 1. That's going to give me 3 minus 1 is 2. So when x is -1, y is 2. And then when I plug 7 into that same equation, because that's another possible x value, then I'm going to have y is equal to -3 times 7 minus 1. That'll give me -21 minus 1, which is -22. So when x is 7, y is -22. So there's 2 points of intersection for that system that we have solved by substitution. Sample 3, we're also going to solve by substitution, and we're going to write our answers as ordered pairs. This, again, is a good choice to solve by substitution since this second equation is solved for a variable. It's solved for y. So I'm going to take my first equation, and instead of where I see y, I'm going to put x minus 1. So I have 2x squared plus 2 times x minus 1 quantity squared equals 26. My next step is simply going to focus on multiplying out my binomial there, x minus 1 times x minus 1. Everything else will get copied. So x minus 1 times x minus 1 is x squared minus 2x plus 1. Then I'm going to use the distributive property to continue simplifying. So 2x squared plus 2x squared minus 4x plus 2 is 26. Since 2 times x squared is 2x squared, 2 times -2 is -4x, and 2 times 1 is 2. Then combine like terms. My 2x squareds combine to make 4x squared. My minus 4x comes down, and 2 minus 26 is -24. So I have a quadratic trinomial here equal to 0. It looks like factoring might be a good choice to make at this point. I am noticing that these all share a common factor of 4, all three of these terms. So I'm going to divide both sides by 4 as a first step. That'll give me x squared minus x minus 6 equals 0. That'll make this a little easier to factor. I could have factored the trinomial up here, but this is simpler. So factoring x squared minus x minus 6 equals 0, I get x minus 3 times x plus 2 equals 0. And then solving this equation using the zero product property, I'll have x is 3, or x is -2. Then I'm going to go back and I'm going to pick the easiest looking equation from the original 2 equations I was given for my system. And it looks like that second equation will be the easiest one to plug x into to figure out my y. So that's what I'm doing here. So I'm going to put 3 in for x, and that's going to give me my y value. Since 3 minus 1 is 2, when x is 3, y is 2. Then I'll plug in -2 for my x. -2 minus 1 is -3, so when x is -2, y is -3. So there are 2 points of intersection. There are 2 ordered pairs that solve this particular equation here, where we see that this would be a circle and a line. So the circle and line intersect at 2 points in this case, and these are the 2 points that they intersect at, 3, 2, and -2, -3. All right, that concludes our samples for this lesson. It's time for you to make sure that this is in your notes and understood, and to move on to the quiz for today's lesson. See you next time.